Okay, so in this video what I am going to do, that I will make a circuit. Let's say this is RP and this is CP, and I have another parallel RC circuit here. Let's say this is RO and this is CO, and we are going to apply V in here and going to take the output voltage here. And now my goal is to make this B out by V in frequency independent. That means no frequency term will appear in this equation. So how we can do this? Let's see. So first let's find the impedance of this part. So let's say this is ZP, and ZP is simply parallel with RP and 1 by j omega CP. Okay, so now we have to apply the formula RP 1 by j omega CP. At the denominator we have to divide these two things. Now we have to multiply RP 1 plus j omega RP CP, and similarly if we find the impedance of this thing, we will get the similar thing R naught 1 plus j omega R naught C naught. Okay, so now you can see that this ZP and this Z naught is series with each other. So to find the voltage V out, we have to apply a voltage divider here, which is V in Z naught plus ZP. Okay, so let's find this thing. This is V in. So what is Z naught? Z naught is R naught. Z naught is R naught 1 plus j omega R naught C naught. Then here RP 1 plus j omega RP CP, then R naught 1 plus j omega R naught C naught. Okay, so this is basically the formula for B out, and if we take this V in at the left side, we will have this thing. Okay, so now we have to make this thing frequency independent. So what I will do, let's say I multiply something like A here, and so I have to multiply A at the denominator. And what if this A is equal to this and this A is equal to this? That means what I want to say, that A is equal to this thing, and similarly A is equal to these things. Then what will happen? This A and A cancels out, this A and A cancels out. That means there is no omega at the numerator. Similarly this A and A cancels out, this A and A cancels out, so there is no frequency at the right hand side. For this condition there is no frequency at the right hand side, and your B out by V in will completely become the frequency independent expression. Okay, so the condition, so this is basically the condition. So for this condition you will have 1 cancels out, j omega, then R naught C naught RP CP. So this is the condition for which this thing is frequency independent. And what is V out by V in? After cancelling all this thing here, you will have R naught RP R naught. Okay, so this is the expression. Now I want to tell you what is the practical case for this thing. So basically I found it in the oscilloscope. You know, if you use oscilloscope, there is 1x and 10x probe, and for 1x probe that is very basic. This is R naught the probe's resistance, and this is the C naught, the oscilloscope's capacitance, internal capacitance. And if you set it to the 10x, then you just additionally apply. Okay, so first let's work with this 1x. So what is the problem with this 1x? Let's say you apply V in and you are going to find V out. There might be some resistance here, so let's assume here is a tiny resistance, but that's not a problem. what I am going to say that, let's say that V in has different frequency. Let's say V in has different frequency. Let's say V in is square wave. So you know from the Fourier series that V in has different frequency. Let's say one voltage is V omega, another voltage is 3 omega, another voltage is 5 omega, and so on. Now for V out, you see that this is the capacitor, and this capacitor's impedance is frequency dependent. So you may see that the V outs B omega is divided by, let's say, 10, this is, let's say, divided by 15, and this is, let's say, divided by 20. So you will get a distortive wave in the V out. So that is problematic because all the frequency components are divided by different values, right? So different values. Why? Because for different frequency, maybe there is some let's say assume that this is omega. Let's say this is okay, you got the idea that here this term is dependent on frequency, this is also dependent, this is also dependent on frequency, and that's why if you change the frequency, the denominator has been changed and V out get distorted. Okay, so now what happens if you use 10x probe? Okay, so now if you use 10x probe, then what happens with this RC? You just apply additional RC. So what this thing is going to do, we have just derived this thing that V out by V in is frequency independent, and which is simply, let's say this is RP, R naught, this is CP, so R naught, this is RP, so R naught plus RP. So this V naught by V in expression looks like this, and if RP is 9 mega, R naught is 1 mega, then 1 mega 1 mega plus 9 mega is equal to 1 by 10. So you see that V out is simply equal to V in, and this is not the dependent on omega. That means if you apply a square wave, and this may have different frequency here, so the output, all the frequency term will be divided by 10. All the frequency term will be divided by 10, and that is so useful. All the frequency term is divided by 10. That means you will have a square wave which is just simply if this is 1 volt, then this will be simply 0.1 volt, but that's not the problem because you have the perfect shape of this square wave. So this is the importance of this circuit.